My name is Elliot Hooper. This is the 2.3 matrix animation project. This is an 8x8 matrix that has 64 total LEDs that run in parallel. I'll talk about later. We have the TPIC and the 595 shift registers. They are similar but slightly different. I'll talk more about that later. Here we have a brightness dial that controls the brightness as shown here at max brightness, and at lower brightness, and then lower and lower and back. And this is the speed dial. This controls how fast the animation runs through. As I get faster, the letters will pass by faster, faster, and faster until, and then back. And the messages displayed in Matrix is coded onto the Arduino from an outside programmer. You might notice that the first row in all of the animations are slightly messed up. This is due to error while soldering. The fourth and sixth column are messed up, and the first row is messed up. An important part of the Matrix animation project are the two shift registers. First, there is the 595 shift register. This shift register is close and similar to the TPIC register with one key difference. The TPIC can take much more ampage than the 595 can. This is important because when all of the rows from the 595 combine and empty through the cathode lead into the TPIC, the ampage is extremely high and would kill the 595 relatively quickly if you used it instead of the TPIC. Both shift registers work in the same way with a data, clock, and latch line. The data sources in the data, hence the name. The clock tells the computer when to accept a new message. The latch tells the shift register when to turn that message over onto output pins. The final important topic to understand is persistence of vision. Using our code and shift registers, we made it so that each row activated once at a time with the columns they need to activate also activating at that right time. Here, using this super slow motion camera, you can see, just barely, each row lighting up in perfect order and then restarting and going back and lighting up again. This is extremely important, not just in this project, but in real life, as plenty of different lights and operations use persistence of vision as it saves energy and allows for more complicated builds.